This is Unit 2, Lesson 2. This is solving exponential and log equations. If you remember yesterday, we talked about finding the inverse of functions, log functions and exponential functions, and we discovered that they are inverses of each other. Today's lesson is where we are only going to have one unknown. So we won't have a y on one side and x on the other side. These are equations, so we have one variable that's unknown, our x or whatever variable we choose to use. I think on all these it's going to be x. And we're going to solve these equations. If you have a weakness in solving equations, you're going to want some practice. You can see me and I can give you some practice on IXL. You're going to need to have a strong foundation in solving equations to be able to work this section. So if you remember, base 10 is what we call the common log. In other words, if it's not stated what base it is, when you see a log function or a log equation or expression, it's always base 10. So we could write it as log base 10x, or you might just see log x, and log x means log base 10x. This is one that we can put in our calculator. We can enter, there's a button on our calculator for log base 10. Let's see if mine will come up. Yeah. Okay, so your log button is right here, and so anytime you use this log button, it is for a base 10 log. So if you look on your notes, we have 4 problems that it says solve the following using your calculator. So where it says log 10, that means log base 10, 10. So 10 to the what power equals 10? It should end up being 1. Let's check and see. On your calculator, you enter the log button and then the number on, and close your parentheses. Get used to just closing your parentheses because there will be times where you'll need to do that. And then hit the enter button and it'll give you the answer, which is 1 on this one, of course, because 10 to the first power is 10. So that's a 1. Number 2, log 50. If we go to our calculator, we would enter, again, log 50, close your parentheses. It just needs to be a habit. And we get 1 point, and then we've got this really long decimal. We want to round to the third decimal place, which is the thousandths. So let's round this to the third decimal place. This equals, or it approximately equals, it's not an exact answer because we're rounding it, 1.699. Log 100, if you enter that in your calculator, you would get 2. Interestingly enough, log 10 is 1, log 100 is 2, so you could probably figure out that log 1000 would be 3, just as the number of zeros is going to be your answer there. But what if I have something like this? I have a log base 2 100. So what this is asking me is 2 to the x power equals 100. How many times would I multiply 2 times itself to get 100? It's not going to be a whole number. It's not going to be an integer. It's going to be a decimal number. There is a way that we can solve these, and if you look down on the next section of your notes, if the base is not a 10, then what we do is we use the change of base formula to solve the logarithm. And the change of base formula says if you have log base b of a, you can enter on your calculator log 10a divided by log 10b, and that will give you the solution to that problem. So in other words, part A, log base 2 100, we would enter in our calculator log 100, and again, close the parentheses, divided by log 2. You don't have to close parentheses in the denominator. If you want to, you can. And that would give us our answer. Let's go over there and do that. So we would enter log 100, close parentheses. Whoops, and I entered too many. Let's try that again. Log 100, close parentheses, divided by log 2, you don't have to close parentheses in the denominator, equals, and we get 6.644. So this is an approximation of what it equals, and you might also see this symbol like this, which means it equals, it doesn't equal it, but it's close to that. We've rounded that number. So log base 4, 64, we would enter in our calculator. Log 64 divided by log 4, and if you go over to your calculator and enter that, you should get 3. Well, obviously, 4 to the third power is 64. But if you don't want to go through that, you just enter your calculator using your base 10 logs. How do I know which number is in the numerator? Well, it's going to be the bigger number, and it's also the one that's kind of, this 64 is above the 4. So in your fraction, the 64 is also going to be above the 4. Log base 389. I would enter log 89 divided by, let's put our parentheses there, log 3, that's so messy. And if you go and enter that in your calculator, you should get 4.086. If you need more practice on this, go over to IXL, the Algebra 2 section. Again, this is where we are mainly because Math 2 is mostly Algebra 2. Go to the Algebra 2 section, go down to R, Logarithms. You see R6 is change of base formula. So this will give you some practice on rewriting these as 2 logarithms, one divided by another, 2 base 10 logarithms. Okay, so we talked about the fact that if you have an x in the exponent or a variable in the exponent, that you can't really solve this without using logarithms. So that's what we're going to do. We're going to rewrite these equations, numbers 1 through 3, I believe. No, 4, as log, we're going to rewrite them into log form, sorry, and then we're going to use that change of base if we need to. So if you look at the steps over here, the first thing that we have to do, though, is we have to isolate the base and the exponent. This is already done that way. So we've already isolated the base and exponent, rewrite in log form, apply change of base if you need to, and then solve for the variable. So we're going to rewrite this as log base 10, 52 equals 2x. So at this point, we need a number over here to be able to solve for x. So we're not going to divide by 2. This is not finding inverses. It's not the same as what we did yesterday. So we're going to use change of base formula to find this number, log 52, divided by log 10 equals 2x. So then we'll go over to our calculator and we'll get this number, and what I get when I round it is 1.716 equals 2x. So then I can divide both sides by 2, and that's when I get x equals, or approximately equals, 0.858. Let's look at number 2. If you remember, the very first step is isolate the base and the exponent. So I need the 5x to be isolated. So I need to subtract 3 on both sides, which would give me 5 to the x power. I said 5x, I'm sorry, 5 to the x power. 5 to the x power is 206. Then I can rewrite it in log form. Log base 5 of 206 equals x. So I brought my x down. It's out of the exponent now. I can use my change of base. Log 206 divided by log 5 will give me x. I'm just going to write equals because it gets old writing those squiggly lines. So in this case, let me go to my calculator because I didn't write the answer on my key. Let's see, log 206, close parentheses, divided by log 5, I get 3.310. I think, let me make sure. 310. Okay, so that is number 2. Again, get used to using those parentheses. Number 3, this time I have an x squared, so this should be interesting, but let's isolate our 4 to the x squared minus 16, subtract 2 from both sides. So that equals 1. Rewrite in log form, log base 4. And then 1 goes here, equals x squared minus 16. Okay. Log base 1 is 0. So when I enter that in my calculator, let's enter this, and what we're going to do is we're going to get 0, because 0 divided by anything is 0. So 0 equals x squared minus 16. There are two ways we can proceed here. We can add 16 to both sides, which is probably the easiest way to do that, or we can recognize this as a difference of two squares and understand that this equals x plus 4 times x minus 4. And if we factor that, we get x equals negative 4 or x equals positive 4. If we added 16 to both sides, we would have gotten x squared equals 16. Take the square root, and that would equal plus or minus 4. Same thing. Okay, so if you see an e, like this number, like this letter right here, this is not a variable e. This is the number e. The number e is a number that we use in banks use it to calculate interest that's compounded continuously. That is lesson 4, I think, for us, so we'll get to that. But the number e is a number. It is a number that is a non-terminating decimal, but it doesn't repeat. It's kind of like pi, but you know, when we use the symbol for pi, we know that that's 3.14 whatever. So the reason I'm telling you about this is I don't want you just to think that's some variable. When we talk about the number e, we use what we call a natural log. This on your calculator is the ln key. So let's subtract 2 first. So we have e to the x minus 2 equals 16. This is, it's basically log base e, but what we enter instead of log base e is we enter, I'm going to erase this, we enter the ln, which is natural log. So we would say ln, and then in our parentheses, we would put 16 equals x minus 2. So let's look at our calculator. You'll see that the log button is here, the ln button is here, so it's natural log 16. And we need to just find that number. So that is 2.77 and then some more decimal places. Instead of, I'm going to write this rounded, but I'm going to leave this in my calculator because you see over on the other side it has x minus 2. So I'm going to add 2 to both sides. And sometimes it's better to leave it in your calculator like that. So the number that we came up with was 2.773 equals x minus 2. So I know I'm going to add 2 to that. I'm just going to leave that in my calculator though and come back over here and just add 2 to it. And so of course it's not going to really change anything with this one, but sometimes we're multiplying or dividing and it's better to leave the number in there and then do the rest of it to that number. So we have 4.773 as our answer. Okay, so let's just make a note here. ln is called a natural logarithm. Where that number e is the base. But instead of writing log base e, we don't want to enter e and then log. We want to, if we use that natural logarithm, it'll use the whole number is the base. Not whole, but entire number. So we're going to switch gears and move into solving logarithm equations. The steps are over here. Isolate the logarithm. So you want the log, the base, and then what's in parentheses here. Rewrite into exponential form. Once you've done that, solve for the variable. It is very important that you actually check your answers on these. And the reason that you want to check your answers is because, and we're going to write this, because we can't have log and then a negative base. We'll put negative number x, or log and a negative number here. Can't have either one of those situations. You will get an error if you get one of those. So we're going to check all of our answers in this section. So let's try this out. We already have the log isolated here. So let's go ahead and rewrite this in exponential form because we have the variable in the log itself. If we had the variable over here, we'd just use the change of base formula, but we can't do that here. So 2 to the negative 1 power equals x. So we're going to write, well, 2 to the negative 1 power is 1/2, so x equals 1/2, or you could say x equals 0.5. Now we need to go back and check that. So let's check 0.5. Log, we're going to plug in 0.5 right here. Log base 2, 0.5 equals -1. Use your change of base formula. Log 0.5 parentheses over log 2 equals -1. When you enter that in your calculator, you're going to find that -1 does equal -1. It checks out, so we can say that either one of these are the same thing anyway, so either one would be acceptable. Next one, we have our logarithm isolated already, so we can go ahead and write this in exponential form. 3 to the 3rd power equals 3x plus 5. Now, 3 to the 3rd power, we're going to need to calculate that. That's 27. And then we'll just solve for x. Subtract 5, divide by 3. X equals 22 over 3. And I'm going to leave it that way. I'm going to plug it in as 22 over 3. I'm going to make this 3 right here, we'll make it a 3 over 1 times 22 over 3 plus 5 equals 3. Okay, so I need to figure out what all this is in here before I use my change of base. The 3's cancel here, so this is 22 plus 5, which is 27. So I can use my change of base, or I can say, well, yeah, I know 3 cubed is 27, so that does check out. But if I wanted to use my change of base, if it didn't work out that way, enter that in your calculator, it would come out 3 equals 3. So then we can say that this is a solution. Okay, I need to isolate the logarithm on this one. By subtracting 5. Okay, so it's now isolated, so I can write it in exponential. 3 to the 5th power equals x plus 142. 3 to the 5th power is 343. Subtract 142, and I get 101 equals x. Got to check my answer. Plug in for x. So let's see, that is 243. You could subtract the 5, you don't have to though. You can just do this part with the change of base and then add the 5 to that. So let's see, log 243 over log 3 plus 5 should equal 10. Log 243 divided by log 3 is 5. I'm not gonna bore y'all with going over to the calculator every time. I'll just tell you. So that checks out, so my answer is 101. My logarithm is already isolated on this one, so I can rewrite this as x squared equals 2x plus 8. Well, I don't have an x squared on both sides, so they don't cancel out. So I am going to have to factor this. I'm going to move everything over to the left side. Subtract 2x and subtract 8 and make that equal to 0. I got to factor this. So I'm going to come up with 2 solutions. So I'm going to have to check 2 solutions. When I factor this, it's x minus 4 and x plus 2 equals 0. X equals 4. X equals -2, setting both of those up equal to 0. And now I need to check both of them. So let's start with the 4. We're going to enter the 4 is right here. So log base 4. And then we have to also plug in the 4 here. So we've plugged it in 2 places. Let's see, plus 8 equals 2. So log 4, and this is 16. And 4 squared is obviously 16, but we'll go ahead and use change of base. Get used to it. You're going to be doing that a lot with our word problems coming up too. So if you enter log 16 divided by log 4 in your calculator, it would give you 2. So 2 equals 2. So the 4 solution checks out. The -2, I have to enter -2 for the base. And then I also have to enter it here. So both places again equals 2. Well, that's -4 and 8, so that's 4 equals 2. And then use my change of base formula. If you enter log 4 divided by log -2, you're going to get an error message. And if you'd noticed, we really didn't have to go that far. I just wanted to show you that even as you get to the end, it's not going to work out, because remember I told you you can't have a negative number as the base of a log. So the 2 does not work out, so this is not a solution. So our only solution here is 4. Okay, last one, and you notice I have another x squared here, so I may end up with 2 solutions again. I'm going to go ahead and put this in exponential form because this is the whole logarithm part and it's already isolated. So 5 squared equals 2x squared plus 7x minus 5. 5 squared is 25. So I need to get everything on one side and 0 on the other side. I'm going to rewrite it because I'm weird that way. I'm going to rewrite it with the x squared and everything on the left, but I'm going to be subtracting 25 here. So it's going to be 2x squared plus 7x minus 30 equals 0. And you notice, and I'm just going to put a note on here, that this a is greater than 1. So we have to use our factoring method where a is greater than 1. If you have a factoring method that works for you on these, that's great. Go ahead and use that. You know I split the middle term. So I'm going to multiply a times c. This is called the AC method. A times c is -60. And then I'll use my middle term. And so what I need, because I've got a negative, because it's a negative, I'm going to need 2 numbers that multiply to -60, but when I subtract them, I get 7. And of course, that's going to be 12 and 5. So I'm going to split this 7 into plus 12x minus 5x and rewrite everything else. The only thing I did was split that 7 into these 2 numbers right here. Then I'm going to group these and factor. So I'm going to take out greatest common factor here, 2x, in parentheses, x plus 6. I'll take out a minus 5 here because I need the x plus 6 in the parentheses again. Remember, if you get the same in both parentheses, you've done it correctly. So my first factor is x plus 6. My second factor is 2x minus 5. This is still equals 0. So x plus 6 equals 0. 2x minus 5 equals 0. X equals -6. That's going to be 2x equals 5. X equals 5/2. So then we need to check both of those. So I think when I check, I'm going to use, instead of 5/2, I'm going to use 2.5. I think it might be easier because it is an exact number. I can use 2.5 and it's not estimating it or anything like that. So let me get rid of this. All right, so let's check the We'll check the 2.5 first. So let's see, 2.5 squared times 2, I'm just going to tell you is 12.5, plus, and then 7 times 2.5, 17.5, minus 5 equals 2. And if you add all these, or add these and then subtract 5, you get 25. Obviously, 5 to the second power is 25. But if we enter our calculator using the change of base, we get 2 equals 2. So that one checks out, and so x equals 5 halves, or 2.5 is one of our solutions. Let's check the -6. So this is not a base of -6. This is just plugging in -6 to this part. So it could work. We shouldn't get an error. Let's see if it works out. So 2 times -6 squared is 36. I'll go ahead and fill that in. Minus 42, because 7 times -6, minus 5. So that is 72 minus 42 minus 5. That's 25. Which is the same thing we got above. So obviously, again, I'm not going to do change of base formula. I'm not going to write it. 5 squared is 25. So this one also checks out, and x equals -6 would also be a solution. So either one of these solutions would work for this one. I believe that is the end of our notes for lesson 2. I'll see you tomorrow.